Alright guys, so now we are going to look about the lecture 6.2, trigonometric equation 1, part 1. So what's the big idea? Well, we need to learn to solve equation with trigonometric function inside. So the main skill you will have to is you should be able to solve by different methodology. One of the big tricks is to use identities so that the equation has only one trigonometric function and only one type of argument in every occurrence of that one trigonometric function. Then solve the resulting equation algebraically to isolate the trigonometric function and use the inverse trigonometric function to find the angle or angles that solve the equation. That's it. So let's try to practice a little bit with the practice number 1. So first of all, you will note that there is only one trig function. There is only one trig function. So we are going to isolate that function. How? Well, 3 tangent of the angle minus square root of 3 equals 0. I'm adding square root of 3 both sides. I end up to have 3 tangent of the angle theta equals square root of 3. I divide by 3 both sides. And so tangent theta equals square root of 3 divided by 3. Which is 1 over square root of 3. Knowing that tangent theta, I know that I'm going to continue, I'm going to write right there, tangent theta equals sinus of the angle divided by cosinus of the angle theta. With the trigonometric circle value function, we are going to end up to have, if we want to have that equal to 1 over square root of 3, we may have to look basically at the angle pi over 6 divided by cosinus pi over 6. And that will give me 1 over square root of 3. There is other value. So see if key values work. And you will see that theta equal pi over 6 will work, of course, but 7 pi over 6 also, 13 pi over 6, 19 pi over 6, etc., etc., etc. When you calculate sinus pi over 6 over cosinus pi over 6, just to remind you that we have 1 over 2 divided by square root of 3 divided by 2, which is 1 over 2 multiplied by 2 over square root of 3. You end up to have 1 over square root of 3, which is square root of 3 divided by 3 when you rationalize your denominator by multiplying top and bottom by square root of 3. You end up to have square root of 3 divided by 3. So the angle pi over 6 is a good angle. Now, if you look at the graphically, what do you have? You will see that at pi over 6 and every 7 pi over 6, etc., you have your function equal to 0. So graphically, you could have also see that. All right, let's jump to the second problem. What I could write here is I could write definitely that my angle theta is equal to pi over 6 plus k multiplied by pi, with k being an integer. K is an integer. Okay? K is an integer. All right, so let's take a look at the practice number 2, and this practice number 2 is cosinus cotangent theta minus cosinus equal negative cosinus theta. So simplify to get only one of the trigonometric function. So because we have two different functions to start, okay, so don't forget to simplify. So what we are going to do is, I'm going to rewrite cosinus of the angle theta multiplied by cotangent of the angle theta plus cosinus of the angle theta equals 0. I can factorize cosinus theta. So cosinus theta is a common factor. So it's equal to cotangent theta plus 1 equal to 0. That the zero product property saying A multiplied by B equals 0, A equals 0 or B equals 0. Therefore, cosinus theta multiplied by cotangent theta plus 1 equals 0 imply that cosinus theta equals 0 or cotangent theta plus 1 equals 0. Cosinus theta equals 0, I know for sure that theta will be equal to pi over 2, 3 pi over 2, etc. Well, actually, let's focus only on this 1. Cotangent theta plus 1 equals 0. This one implies, let me do this right here. Cotangent theta plus 1 equals 0. So we have cotangent theta equal negative 1. And that is going to imply that theta will be equal to 3 pi over 4, 7 pi over 4. To stop right here. Okay. And when you look at the graphically, you can see, let's see if I represent this with the angle pi over 2 is right here, and we have 3 pi over 2 right there. But I have also, let's do that in blue, I have also 3 pi over 4, 7 pi over 4 right here. Okay? All right, let's go on the practice number 3. In this practice number 3, again, as only one trig function, okay, so we have one as only one trig function, and we are going to use, okay, and we are going to use algebra to solve this equation. When you look at that, you should be able to see that we have, this is a quadratic like equation. Okay, why? Because it looks like ax squared plus bx plus c equals 0. Okay, with x playing the role of sinus x. So obviously, if you have 3x squared plus, I can do that, plus negative 2x plus negative 2 equals 0. You have several ways to solve that problem. The first way is to try to see if you can factorize, and it's kind of easy in this way because you are going to end up, so if we have 3, let's do this way, 3x squared plus negative 2x plus negative 2 equals 0, you can end up to have 3x plus 2 multiplied by x minus 1 equals 0. Now you have been able to factorize this quadratic-like equation. You end up to have 3x plus 2 equals 0. So 3x equal negative 2. That means x equal negative 2 over 3. Remember that x is equal to sinus of the angle lowercase x. So I end up to say that sinus x equal -2/3. Because I'm looking for lowercase x, I'm looking for the angle lowercase x. What I'm going to do is I'm going to use the inverse function. Okay, I'm going to use the inverse function, and I'm going to write x equal sinus -1 of 2/3, and that is going to give me the value of x around -0.729728. And obviously, I will end up to have also, let me write that right here, also x would be equal to pi plus 0.729728. Now, if I look at the other one, and actually, you know what, I'm just going to erase that right here and put it a little x squared plus bx plus c equals 0. Like this right here, I'm going to have x minus 1 equals 0. So that means x equal 1, which is basically implying that sinus lowercase x equal 1, and that means x equal pi over 2. And so we end up to have three solutions. The first solution is going to be this one. The second solution is going to be pi plus 0. Blah blah, and it's going to be around 3.871721, if I'm correct. So that will be the second solution. And the third solution is going to be x equal pi over 2. And that is going to be the third solution. So we're having three solutions. We're having three solutions, okay? And if you are looking at the equation, like a quadratic-like equation, we're having these three solutions. We're having the last one right here, pi over 2, it's right there. Then we're having another one, which is 3.8. So the 3.8 is the orange one. So I'm going to be around here. And I got another one, which was, what did I say? Negative. So obviously the first one is right there. Okay. And it continue so forth. All right, so let's try to do the next one. Problem number 4. All right, guys, so on this problem number 4, solve cos square x plus 2 cos x minus 1. I'm going to let you do that by yourself. And I will ask you some questions regarding this problem on the head puzzle. So I will let you do this one, and as well as the problem number 5. Same idea. It's not because you are dealing with a cotangent and cosec. So let me just give you a hint, and then we move on for this problem number 5 right here. All right, so guys, first you need to transform cosec in terms of cotangent. So you follow step number 1. And then you are going to substitute the expression of cosec you found right here inside your equation, and then you will solve the equation applying the same methodology than previously. Good luck and see you in class.